You have probably seen the hype reels. Agents are the future. Fire your workforce. Let the LLM handle it. Cool down. Before we replace anybody, we need a clear picture of what an agent actually is, when to reach for one, and how to keep the thing from blowing up in production. So grab a coffee and let's walk through a no nonsense roadmap. 11 minutes, one breath, zero buzzword bingo, based on OpenAI's own practical guide to building agents, plus the scar tissue from real deployments. First, the line in the sand. A chatbot that answers a single question is not an agent. An agent is a system that owns a workflow end to end. Think of a savvy executive assistant. You say, book me a flight, find a hotel near the venue, and expense it. The assistant figures out the steps, calls the airline, checks your loyalty number, decides whether the fare is refundable, and only loops you in if something weird happens. Replace the human with an LLM plus a toolbox of API, that is an agent. Two non-negotiable traits separated from plain automation. One, it can reason in ambiguous territory, no brittle, if price is less than X rules. Two, it wields multiple tools, APIs, databases, even GUI clicks to fetch context and then take action, not just spit out text. So, should you build one? Ask three limit questions. One, is the workflow full of fuzzy judgment? If approving a refund sometimes requires reading angry paragraphs and sniffing for fraud, rules engines choke, agents thrive. Two, do you maintain a jungle of brittle rules that break whenever a policy changes? If your logic doc looks like spaghetti, an agent can simplify. Three, does the job rely on unstructured data, PDFs, chat transcripts, scanned invoices, where deterministic parsers flail? Tick any of those boxes and an agent might be worth the headaches you are about to inherit. Assuming the answer is yes, the skeleton is simple. Model, tools, instructions. The model is the brain. Bigger models reason better, but burn cache and latency. Smaller ones are cheap, but miss nuance. Start fat. GPT-4o or similar, establish a baseline, then swap in fast models where they still hit the mark. Tools are the arms and legs. Three flavors: data tools for looking things up, action tools for writing back or sending emails, and orchestration tools. Yes, an agent can call another agent like Russian nesting dolls. Each tool needs one-line docs, version control, tests, and a tight schema so your brainy friend knows which knobs to twist without hallucinating function names. Finally, instructions. Fancy term, system prompt. Reality, a stapled collection of your existing SOPs, standard operating procedures, rewritten in bullet points the model cannot misunderstand. Includes edge case branches if user does not give an order number, ask twice, then transfer. So the agent does not improvise a Shakespearean monologue. Once you have gotten those parts, choose your orchestration pattern. Pattern 1, single agent loop. One model, one instruction set, plenty of tools, running in a loop until it either produces a final answer, calls a done tool, or exceeds a retry limit. 90% of early wins live here. Pattern 2, manager model. One top-level agent delegates to specialist sub-agents. For example, a translation manager that decides when to call Spanish bot, French bot, or Italian bot. Pattern 3, decentralized handoffs. Peer agents tossing control like rugby. Great for triage systems. A front desk agent detects a billing question and hands the conversation to a finance agent, which may kick it back if the customer suddenly complains about product defects. General rule: squeeze juice from one agent first. Only split when prompts turn into Toy Story or the tool list looks like an app store. And then the guardrails. Think of them as TSA for your agent. Metal detectors, sniffer dogs, random pat downs. You never trust one layer. Typical stack: a relevance classifier that kicks out off-topic user acts. Write me a sonnet when your refund bot should only manage money. A safety filter that blocks jailbreaks or attempts to leak system prompts. A PII scrubber, personally identified information scrubber, if the bot might expose customer addresses. And plain old rejects block list for forbidden terms because sometimes dumb works. Each guardrail runs in parallel with the main loop. If one trips, you either refuse, sanitize, or escalate to human. Human in the loop, yes, that is still required. Two triggers, you exceed a failure threshold, say 3 attempts to match an intent and still no luck, or you are about to execute a high risk action like issuing a $1,000 refund. At that point, you raise a flag, shuttle context to a human dashboard, and let flesh and blood finish. Over time, track which interventions were unnecessary and tighten the instructions so the model learns. Track which interventions saved your bacon and codify them as hard stops. Let's stitch this together with a real scenario: payment fraud review. You feed the agent a transaction ID. Step 1: the agent queries a transaction database via a data tool. It sees an overseas IP, unusual device fingerprint, and a previous chargeback. It calls a second tool to fetch the customer's dispute history. Next, using instructions lifted from your fraud playbook, it decides risk is high. Before refunding or blocking, the guardrail for transactions over $500 triggers a human review requirement. The agent packages its reasoning and evidence into a JSON blob and opens a ticket for a human analyst. If the amount had been $50, the guardrail would stay silent and the agent would execute an action tool to block the card automatically. One loop, 3 tools, 2 guardrails, and a clean handoff path. Couple of mistakes teams make early. First, tool sprawl. They hook up 20 overlapping APIs and wonder why the model calls the wrong one. Distinct, well-named tools or bust. Second, prompt novels. Long paragraphs drown the model. Break them into numbered objectives and short constraints. Third, metrics blindness. Ship an agent, then stare at anecdotal success stories. No, you need evals. Choose success criteria: accuracy, latency, cost. Run test suites and store at every run. When you swap GPT-4o for GP Turbo 3 font size, you will know if savings outweigh drop-offs. On cost, a quick sanity check. Large model calls at enterprise rates might run a few cents per 1,000 tokens. If your agent loops 10 times per user and each loop burns 2,000 tokens, you are looking at 20 cents a session before infrastructure. Tool execution, database reads, third-party APIs, adds more. Multiply by daily volume, slap on a 30% buffer for hallucinated retry loops, and you have got a ballpark. CFO hates surprises, so you have to measure first. Latency is the other beast. Users tolerate maybe 4 seconds before they alt-tab. And some tricks: you should offload lightweight tasks to a small model, intent classification, simple extractions, stream responses token by token so the user sees partial progress, and parallelize, fetch context from 2 data tools at once rather than serially. Now, about model selection. Start with top tier, but once you have proven quality, swap smaller models selectively. Example, GPT-4o for the core reasoning, but an O3 Mini or Cloud Haiku for lookup or summarization tasks. You save costs without a quality creator because those subtasks never needed full horsepower. Set up automatic evals so you know when you have pushed frugality too far. Testing and rollout. Pilot with mock data and staging, then limited alpha on real users. Instrument everything: each tool call, each guardrail trigger, user satisfaction thumbs up, and any manual override. After 2 weeks, you will know your agent's personality flaws better than your pet's. Patch instructions, retrain guardrails, and expand exposure gradually. Let's roam into future proofing. The guide hints at computer use models, agents that literally control GUIs when an API doesn't exist. Picture the agent opening the SAP interface, clicking create invoice, typing fields. That is powerful but terrifying. You will want screen recording, synthetic test users, and stricter guardrails. Another frontier: agents as tools. Your refund bot itself becomes callable by a high-level customer journey agent. Nesting agents is elegant but can explode complexity. Monitor recursion depth and give each child a strict budget of steps. Security reminders. Treat tools like microservices, authentication tokens, scopes, read only where possible, rotate keys, and log every write. Models can hallucinate SQL injection strings, sanitize parameters before hitting a database. And yes, limit the agent's action tools so a runaway loop doesn't DOS your CRM. Finally, culture. Rolling out agents changes workflows. Some staff will love offloading drudgery, others will fear replacement. Solve that by positioning the agent as a co pilot. It drafts, humans approve, every approval updates your eval set, slowly promoting the agent from intern to associate to senior. Celebrate human catches as much as autonomous wins. Wrap up rapid fire. Define the right use case, nail model tool instruction trifecta, start single agent, layer guardrails, plan handoffs, instrument everything, and iterate. Do that, and you will ship an agent that delights users instead of generating apology emails. Skip any step, and you will spend next quarter debugging while your shiny AI sent refunds to the wrong continent. Your move.